Hi, the next topic is defining a function. So we can define any function in R. So this is the simplest example, one of the simplest examples. So f of x is equal to x squared. So we want to develop this function. Then at first we declare the name of the function. So we define the function named square here. Then this is a function. So we define this as the function parenthesis x, parenthesis, then brace, then x square, then brace. So then we have defined the function square as f of x is equal to x square. So after we defined this function, if we type square of 9, then we get 81. Square of 1.7, then we get 2.89, and so on. Okay, think about a little bit more complicated function. So remember that in our previous video, we want to find the smallest integer n such that the 2 to the nth power is larger than given number capital N. So this lowercase n represents the binary length. So length as the binary expression of capital N. So capital N is any number. So now we want to develop a function to return the lowercase n given capital N. So this is the function we can define. So given capital N, okay, so we define the binary length function. So this is the name of the function. And this is a function of capital N. And we start with lowercase n is equal to 1. Then while 2 to the nth power is less than capital N, we increase n by 1. Then finally, we finish this repetition, then we return n. So the output of this function is n. So to declare output, just you can type the output. Then after we defined this function, the binary length of the 1, 2, 3, 4, 5, 6, 7, 8, 9 is 27. Maybe we can run this function in the R console. So binary length function. So binary length. So capital N should be a positive integer. So 1 in the decimal system is also 1 in binary system. So length is 1, so it returns 1. So 2 is in binary system 10, 1, 0, right? So the length should be 2, and actually it becomes 2. And 3 in the decimal system is 1, 1 in the binary system. So length should be 2 and 2. And 4 is 1, 1, 1, 1, 0, 0 in the binary system. So it returns 3, and so on. So if we return 16, 16 is 1, 0, 0, 0, 0, so should be 5, and actually it is 5. So this is how to define the function. Here, the plus sign that also appears here. So this just means that the R run this code. So the code continues from the last line. So we are defining a function, and the definition has not been finished until this line. So that's why we have plus signs there. Okay, so next we want to get a little more general function. So we thought about decimal system to binary system, but in general, the q-adic system we can generate. So binary system 1, 1, 0, 1, 1, 1, 1, 1, and so on. But for example, the 3-adic number, that is the 1, 2, 1, 0, 1, 1, 1, 2, and so on. So last time we think about the 2 to the nth power, but this time that we think about the q to the nth power for general q, general the positive integer q. So the input of the function is not only capital N, but also q, the base of the power function. Then again, we start with n is equal to 1. Then while q to the nth power is less than capital N, we increase n by 1. Then finally, we return n. But also, okay, so this time we generalize the output that we put another output, the q to the nth power. So not only the n, but we can get the q to the nth power. If we define this function, the q-adic length of 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 is actually this. So actually the 17th. So 17 is the length when we express this number in 3-adic system. And this is the 3 to the 17th power. So if we put 2 here, then it returns the same output as the previous function, binary length function, but here that we generalized function. And also that we can set the default numbers for functions. So for example, the previous function, q-adic function, okay, so usually we want to think about the binary length. So 2 is the default value for q. Then we can specify this. And also, if you want, you can define the default value of capital N in this way. You don't have to, but you can specify the default value. So in this case, if we don't specify anything, the default value of 2 and this capital N are used. So it returns the same result as we give q is 2 and n is 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can change the q value here. Then we can get a different result. So this is how to define functions in R. And one note, you can set any objects as input of a function and the output of the function also. So sometimes, for example, we want to clean the data set. So input is the data set, so data frame in our object. And the output is the cleaned data set. So again, this is data frame. And we give parameter to clean the data. Then maybe input is a data frame and a parameter, and output is a data frame. So anything can be an input and anything can be an output of a function. And here is an example. So this is a little bit a simpler example, but a function whose input is a function. So this function f10 is this. So given function f, we calculate f of 10. If we input cosine here, then we calculate cosine of 10 radian, and so on. So if you defined this function in R, then f10 of square root is we evaluate this function at 10, so square root of 10, so it returns the 3.16.